Hello everyone, hope you all are doing great. I am Preeti, your host for today's session on Internet of Things IoT, connecting the physical world. I am excited to introduce our distinguished speaker, Mr. Kunal, an award-winning product leader with over 8 years of experience in developing and scaling deep tech solutions across IoT, wearables, hardware, SaaS, and consumer electronics. As a founding member at two startups, he has successfully driven B2B, B2C, and B2B2C product strategies, led team from 5 to 55 members, scale connected hardware deployment to over 150,000 devices, and contributed to company's growth from a valuation of $0.8 million to $50 million. Recognized globally for his contribution to product innovation, his products have received prestigious honors including the CSE Innovation Award, European Product Design Award, and India's Best Design Award, along with 40 plus patents filed in IoT and connected hardware systems. Kunal's expertise lies at the intersection of hardware, software, and design, transforming early stage ideas into market ready, scalable product. With a strong passion for building impactful technology and mentoring the next generation of engineers and product leader, he brings a practical holistic perspective to IoT systems, product strategy, and end to end development. We are truly honored to have him here with us today to share his expertise and insights. So let's give him a warm welcome to Mr. Kunal. Over to you, sir.
Thanks for the introduction, Preeti. Hi, everyone. I'm so glad to see you all here. First of all, thanks to Shine.com for organizing this and inviting me to share my thoughts with you all. Uh, and like the intro was that was really really elaborate. Thanks for that again. Honestly, titles and awards aside, I am just someone who loves making real products, making real solutions, something that you can hold, use, and actually that solves some problems. So today I'm going to take you all on a journey, not just about IoT projects or IoT. I'm going to take you on a journey about IoT products. There's a huge difference between these two, and I hope you guys may learn some things that I wish I had known earlier in my career. Shall all right, let's start in that case. Just a second. Let me share my screen. Yeah. Okay. So before we all dive deep, let's make this interactive. I am told that this session is mainly for freshers and like some guys with 3 to 5 years of experience. So I'm assuming there are a lot of us who have not touched IoT or electronics, and like some may have worked on a few small projects, and some may have built many products as well. So let's drop a zero in the chat for somebody who has not touched electronics, a one for few small projects, and two for somebody who has built end-to-end products. Let's see who we have got here. Nice. Wow. Okay. A lot of beginners here. And yes, nice. We have got some pros here too. And that's great. Okay. All right. So here's what we'll cover today. I'll skip the introduction since Preeti has already covered it. Yeah. So here's what the agenda of what we are going to do today. Like I'll just brief you out on it. So we'll understand IoT fundamentals, and we'll see a simple live demo of how IoT data is sent to cloud. So when people hear IoT, they just think it's just electronics. It's not just electronics. We'll see the whole deep dive into the product development life cycle, and what all components does it include, and like what's a basic difference between a project and a product. And we'll take some career opportunities, a look at career opportunities in the session as well. And at last there would be an AMA session. You can ask me anything at that particular point, and the goal is to basically make IoT feel less intimidating and more like a tool that you can use to solve your problems. Okay, so let's dive deeper into what is IoT? So as you guys can you understand, like IoT is Internet of Things, and like it's uh, basically about making physical things talk to each other or talk to somebody, right? Like so that we can see what's going on in a physical device. So I have a water bottle here, and that water bottle like can if it can talk to my mobile, that would be an IoT. That is it. Whether it's your smartwatch which tracks your steps, whether it's an Alexa, it's all IoT. So if I had to explain it to my parents, I'd say like it's like giving physical things, everyday things, a little brain and a human interface to talk to. And but here's the exciting part: IoT is not just about coding, as I said, or not just about electronics. It's about electronics, mechanical design, cloud, and user experience as well. This is why, like, it just feels like a playground. And if you see like there generally are four layers in IoT. I'll first tell you some perspective of why IoT is so important. So if you read go ahead and read about IoT a little bit more. There are 15 billion connected devices right now, and we are targeting to close almost 30 billion devices. And the best thing that IoT is industry agnostic. When I say industry agnostic, it means you can fit it into any industry, whether you're working in health tech, whether you're working in fintech, agriculture, logistics, consumer electronics, manufacturing, doesn't matter at all. It's gonna be like electricity, or you can say like something like an internet, right? Like it's gonna be everywhere. And along with AI, LLMs, IoT can do wonders. This is an opportunity I believe most of you, the passionate ones, would be working on for the next 10 years in this space. And what's amazing is that basically we are at a point where individuals can do a lot more, and we don't have to be dependent on just some big corporations. So yeah, like you guys can work a lot in the IoT domain itself. So yeah, let's just understand what are these layers in IoT. So the first one, as you can see here, is the perception layer. This is where the devices, the sensors are there, right? So like you perceive the world with this particular layer. So you can imagine something like as I said, like the water bottle. Let's stick with that example. So like something that can sense the temperature of the water, something that can sense the like the level of the water. That would be the perception layer. Then the second thing is the network layer, which is basically sending this data to something, basically to a network, right? So network basically sends the data. So there would be some hardware involved here, which would be sending data to somewhere. I'm not taking any names right now, but like let's assume it can be anything. It can be cloud. It can be any other thing as well, right? It can be a mesh, anything. So yeah, the next stage is the cloud layer, where the real processing happens. We try to offload all the real processing to the cloud, because like in IoT we are always a resource like running on low resources, very low resources generally, because like it's generally a very small piece of hardware which has to do a lot of things. So we don't do compute here. What we do is we try to rely upon cloud, and for some small things we can do the compute, but it mainly depends upon the application. So if you think Tesla does a lot of compute on the board, on the edge, right? But if you think about something like a watch, it doesn't do a lot of compute. Most of the compute happens on the cloud itself. So yeah, it mostly depends upon how much can you fit there, rather than what needs to be done, right? And the fourth layer is the application layer. This is where all the visualization and business decisions are made. So like just like the Fitbit application that you would see on your phone, or the like the Tesla screen that you'd see on a Tesla, that is the application layer, which is talking to the human interface. So again, going back to the example that I said earlier, uh, like there's a little brain which is doing all this perception and networking, and then the human interface, which is the application where these value creation can actually happen. Yeah, so like there are a lot of buzzwords in the industry, and yeah, it always happens after like almost 5 years. These buzzwords get replaced by something else. So yeah, right now in AI, there's a lot of buzzwords going on, but let's stick to the IoT part. So I'll tell you a little bit about the buzzwords and what do they actually stand for. So like there are I've tried to cover four of them. So if any one of you is from software, you would know it, but like this is mainly for everyone. So like three of them are covering the software part. So broker is something like a basically like a messaging hub in between devices and something else. Let's assume there's something else. Okay, so you can take an example of a real estate broker. So what does a real estate broker does, right? Like it connects one person to the another, a publisher to a subscriber, right? Somebody who wants to sell, somebody who wants to purchase. So it connects both of them together, and like just validates how you guys are going to talk to each other, right? Like you don't discuss my commission with them, I won't discuss your your part with them, right? So just like that. So that is what a broker does. Like has some protocols, has some like a publish and a subscriber based technology. Then we have gateway. What a gateway is basically, it's something similar to a Wi-Fi, which so your Wi-Fi can connects to your phone to the internet, right? Like a Wi-Fi router. And gateway is very similar to that. Let's assume we have a bunch of devices which are talking over Bluetooth, and there's a gateway device which is connected to internet. But like these devices, the ones who are talking on Bluetooth are not connected over internet right now. So what this gateway does is basically connects them all together and gives them access to the internet. So device connecting the sensors to the cloud. Then comes the client and server. I think this is very simple. Like a communication where like basically client is sending requesting something in some info, and server is serving it. So it's basically who's asking and who's serving, similar to a restaurant. Like you would ask for a order, and the kitchen owner or the restaurant owner would be serving you your food, right? So client and server, very similar to what we use in a daily life. And the like another buzzword is basically WebSockets. So WebSocket is basically like a phone call which keeps you dialed in, and you can hear what the other side is saying. So you can imagine a server and a client, or rather let's imagine a dashboard and a device. They are both talking to each other on a WebSocket. They both can talk to each other on WebSocket, which is like a constant phone call. The front end is listening to the device constantly, and how are they all talking to each other is defined by different protocols. So yeah, like this is a really good example. Like HTTP is like a knock on the door. You knock and you wait for the response. MQTT is like a group chat of the devices. And yeah, that is it. And other than that, like there are few things that you're going to hear a lot from me is like sensors and actuators. I believe all of you know about it, so I won't deep dive much into that. But you can compare your sensors with human sensors, and actuators with the are something like a muscle, or which make things happen. So which actuates things, right? All right. So this is the like I'll first cover the boring part, then the interesting part would be saved for the last. So this is the system architecture mainly. When I say system architecture, this is one of the main things of what I do personally at as my role. So like a lot of system architecture definition is goes into defining how things are going to talk to each other. So let's start from the left side, which is the sensors and microcontrollers. Let's assume there's a temperature sensor on the left. Okay, which is so there's a broker in the middle who's like broking the connection between the publisher and the subscriber. Let's assume in this case the publisher is the sensor. Sensor wants to send the data to the cloud. Okay, I'll come to the hardware part of things in a while, but let's understand the architecture first. So let's say the sensor wants to send the data, and publish the data to the cloud. And the best or the industry standard right now is MQTT broker. You can send data via any other method as well, but MQTT broker is the best, considered best right now, since it avoids any you can define the quality of service in the MQTT protocol as well. So MQTT is covering this, collecting this data, sending it to the cloud, and then there's a backend server which is having all of this data, and which is then, the dashboard is showing that all of that data via multiple method. It can be either a WebSocket or an HTTP or MQTT. It totally depends upon the use case. But in this example, there's a MQTT which is going outside the backend server to the dashboard just for the urgent messages, or if there's an anomaly, you can consider that. So this part right here, this part, like this is where an anomaly can be shared with the device, with the dashboard, so that it hears right away. And the WebSocket, or even the HTTP, is like something which can happen async, and doesn't really matter a lot. But devices can also send the data via HTTP and MQTT both. So there's one small mistake here. You can consider the IoT devices sending this data directly via HTTP without a broker in between. Okay. Yeah. Okay. So the demo, what we'll try is, basically, we'll try to see how this whole flow works, like sensor to microcontroller, then to MQTT network, then to cloud and the dashboard. The tools that we'll be using would be Adafruit. If you guys know, it's a cloud platform which gives you access to the MQTT and the cloud simultaneously. So yeah, I'll just share that part of my screen. Give me a second. Yeah, let me just deep dive a little bit here in this small section, which is the sensor, microcontroller, MQTT, cloud, and dashboard. So sensors, I'm sure, you guys know what I've been talking about. Microcontrollers, I'm sure you guys also know about that. So you can consider something like an Arduino, an ESP32, or a Raspberry Pi, like something which is able to compute some XYZ things that we want to do, right? Other than that, Wi-Fi, BLE, LoRa, 5G, LTE are something which are the part of the network or the connectivity layer. And this is what happens when a microcontroller tries to share the data to the cloud. This is what they use. Any of these communication protocols, you can say. And yeah, I think we have covered the rest of the part.
Uh, Sir, your screen is not visible.
Just a second. Yep. I hope my screen is visible now.
Yes.
Okay, perfect. So this is the IoT Adafruit IO dashboard. What I'm trying to do here is, as you could see in that demo steps, you can go ahead and make a free account directly from the sign up site. And then we what we need to do is we need to make a the first thing is basically like a feed. So this feed is nothing but a data which is coming from a sensor. Okay. So that part, I won't be covering the data from the sensor in today's session, but yes, I will tell you how to make a MQTT connection and do this dashboard yourself. So let's just take an example of temperature. Temp Yeah, let's just create a feed. Okay, the temp is done less than a minute ago. then we can directly go ahead and create a dashboard. It's very, very simple. Demo test. So I'll go inside the demo test. I'll edit add some blocks, like let's say add a gauge, and I'll connect that gauge to the temp part. Okay. So this is the sensor, which is like this is basically from the sensor value. Okay. So this will show the sensor value once we send some data here, and then let's import a graph as well. It's very, very simple. You can use it as like as simply as you want. Like it's just creating some blocks, and this will be connected to the data that I'm going to push now. Okay, I'll show you how to push that data, but let me just edit this layout a little bit. Yeah, done. Okay, all right. So now I'll just okay, I'll just connect to this particular feed now. Okay, I'll try and send data to this feed. Okay, and for that you can refer to this particular MQTT help page that is created by Justin Cooper. It's really good. Explains what topics are. Explains how you can do the whole thing. I'll just take this example only and help you out in making the first MQTT connection. Let me share my full screen again. I hope my screen is visible. So yeah.
Yes, it is.
Okay. So I'm using this platform called MQTT Explorer. I'll start with a new connection. Let me just open it again for your reference of how things work here. Okay. So I'm just making a new connection here. I'm just giving it a name, add a fruit test. We will use the TLS, and this host, as you can see here, it's io.adafruit.com, and port will keep 8883. When we have enabled TLS, we need to keep 8883. And this username and password, this is mainly the IO. So AIO, what it does is gives you these these basically API keys for making the communication. I'll just use my username here, and I can connect to this particular dashboard. Right now, if you see MQTT error, not a valid topic format, yes, because like we haven't configured the topics right now, but you can see like right now there's nothing coming here, right? Now what I'll do is I'll just see what these guys are saying. So if you see, they're saying like you can keep the topic. So these topics are generally very, very independent. Like in your own, you can name the topics in your own language, and you can do whatever you want here. There's no restriction here. But like when designing a system, I would obviously suggest to keep it as generic or as expandable as possible. When I say expandable, it simply means that you can you can keep some variables here, which would be defined by your server. So that is what these guys have done. So this is a variable. This is a something which is what we are connecting to, and this is again a variable, the same variable which we have kept here in the feed. So as you can see, I've kept the variable name as temp, or the feed name as temp, and same here. And now I'm gonna send some temperature values, and I have got it here. Okay, I'll just show it to you again. So let's just keep some random numbers as well. So you can see. So this is happening live. This MQTT broker. Imagine this being on some other machine. It can talk to the same dashboard in the same way. Imagine this being that water bottle that I talked about. It can talk to that same way. right? So this MQTT broker can be on any different machine, that it's not really dependent on that. And imagine your device is sending this data on this particular topic only. So this MQTT Explorer is kind of like a client or a dummy device in this case, which is sending dummy data to this particular dashboard, which is like ingesting this data, and we are going to see it on the dashboard as well. Yep. So you see it right here. Let me just, so imagine this being your device itself. Just a second. Let me do it like this. Yeah, this is much better. Yeah. So imagine this side being your device, and this side being the application side, which is consuming the data. You can see like the timestamp, the actual value. You can see it all, right? Let me just play around and send it a little bit different random values. Like that. So you can see all of this data. When I said it is gonna be connected to the feed, this is what I meant. It's that like this whole data is connected live to that particular feed, and this is how you can also do your own IoT demo. That's it. Like it's very very simple, because like tools like Adafruit have helped a lot in making these things very simple. Just a second. Yep. So we have covered this part. We have like, so the device, like you can do that part as well, like after searching it on the internet. So this is what a Adafruit, this is what a ESP32 looks like. I'm sure you guys have seen it multiple times. You can connect an ESP32 with a very very simple method, and like the world that we are living in right now, LLMs can help you a lot in doing a lot of those steps. And I've just shown you how we can use this MQTT part to publish that reading and visualize that on a dashboard. And to do this whole thing yourself, you would need different expertise. But for a POC, this would be good. For a proof of concept, this dashboard would be good. And you can use multiple different dashboards, like Adafruit is one. Then we have a Blink app, which is available on the phone. You can use that in a very similar way, and it connects to the similar feeds, and you can connect it to the sensor value directly, or you can use even some values to trigger some actions based on those sensor readings. So Blink is something that is being used since almost a decade now. And yeah, it's very very reliable. Even Adafruit is very very reliable. You guys can go ahead and check it out. I'm sure not a lot of you would have ESP lying around. So yeah, like I'll skip that part. Okay. So from projects to products, like I am sure you all of you would have worked a lot on one or the other projects, right? But like the DIY projects can be built, like there you can build one DIY project. That's not going to be a very big challenge, but scaling that product, which is going to be used by thousands, there's a huge difference into it. So like tinkering, as I say, is not at all equal to product, never. And projects are generally built for testing an idea, or doing a proof of concept, and the components involved in it are generally around like the POC level hardware. You can use a breadboard to validate it, and this is where it all starts. Like every product starts from this particular thing, but people generally tend to leave it there because like they think they've made something good. For example, I've made almost 300 projects in my life, but only 30 of them were qualified to a product. So that you can understand the scale of things that are needed to make a product. So generally, these are all the components that are involved: the hardware, software, mechanical, firmware, connectivity, and software. And yeah, software I already covered. But in products, there's a lot more. Other than these all things, like so software part, you need to have a dedicated back-end, front-end, and a cloud, and procurement, manufacturing, operations, quality, and support. So like there's a lot many things that go around in building a product. So in an Apple Watch, you can understand there would be a supply chain management team, a production team, before after the R&D guys were finished, their tasks were finished, their projects were finished. After that, these guys would have taken over and maintained the quality so high that we are all ready to pay such a high price for such a great product, right? Okay. So I'll jump to the product life cycle. This is where, like, this is the basically the journey. This is where we are gonna spend a lot more time than the other slides. So most beginners stop at making like the first step, like making the cool projects. And but as I said, like taking something from a project to a mass production level, it's a whole different journey. I'll deep dive into each one of these steps. Okay, so so proof of concept is generally, as I said, it's to validate the idea, but it's to validate the idea if it's technically feasible or not. And our focus in this particular step is generally about just to make it work, rather than beauty. It's just to make it work. So it's always speed over beauty in this particular case, in just the POC phase, right? And often, like, you can consider something like a single use, a duct taped or a hand built prototype. Even that works here. So that's why breadboard is our biggest, biggest friend when we start with our journey. In this particular step, you would have your biggest friend would be a breadboard, I would say. And you shouldn't care about the looks, the scalability, or the cost as well. So people get a lot stuck in the cost part at the POC. You shouldn't care much about that. You should just try to prove the concept that you have thought, whether it is feasible or not. And once your product, like once your POC works, you go to a minimum viable product. And this is just enough product that some users can try. So let's say that bottle example, it can just be a bottle with a 3D printed cap, you can say. And which can be used, which can be opened, and you can drink water out of it, and it still communicates to your phone. But that app may not look very good. That's okay. But the goal here is to test your concept, or test the assumptions that you have done. So there is a lot of assumptions that a person makes during while making the product, and not all of them are right. It has happened with us many times that our assumptions were failed by market, and we didn't find the product market fit, right? And so this is the step where you find your product market fit. And like, it's basically the best way to see if your idea is solving a real life problem. And like, just a quick question here. If you guys know, just share the data on the chat. So do you know which product did Zomato decommission or close due to no product market fit? Like, very recently this happened. I think last year itself, they closed one big division just because there's no product market fit. Okay, I don't see much replies here, but okay. Let's just wait for a while, then we'll answer it in the end. Okay. Yeah. So next step is basically your engineering validation test. When you first you have found your product market fit, now is the time that you do uh, your your engineering choices. Whether this sensor that I have selected, is it right for this particular market or not? Whether the microcontroller that I have selected, or the competition, whether it needs more competition, whether the interfaces that I've selected, whether it is right or not. So you validate all of your engineering concepts, engineering assumptions. And this is where like your engineers or you engineers take all your learnings from the PMF and start locking down your technology choices. Like everything has to be locked down in this particular phase. Am I is it too quick? I think somebody messaged quick here. All right, I'll slow it down a little bit. So yeah, this is where basically okay. Yeah, this is where the IoT projects start to feel like serious hardware engineering. This is the place where FMEAs are tested. So all of you who don't know about FMEA, it's basically failure mode effective analysis. You test your all of your failure modes of the hardware itself. Then comes the DVT part, which is a design validation test. This is where you focus on the looks, you focus on the feels, you focus on the UI and the UX. So every product has a UI and a UX. It's not dependent on the software or hardware. This is where this is the step where we validate that. And once the tech is stable, we refine the design, and like DVT makes sure that it looks like the final version. And you can consider like if AVT is about the brains, the DVT is about the usability side, the usability, beauty, and durability as well, right? And the scale as well is very very different. I'll come to the numbers as well. So how many should you like prototype in each phase? I'll come to those numbers as well. And then comes our almost final stage, which is called a PP or a PVT, a production validation test or a pilot production. You can call both of them are almost same. So this is the final stage just before mass manufacturing. You validate your assembly line processes here, and you test whether the process is all repeatable or not, and you test for large scale productions, QA, and packaging. This is where an IoT product basically becomes a real product, and not just a cool demo, right? So it has all the parts of DFM, DFA, which you validated earlier, coming to life in this phase. And then MP is obviously, I'm sure you guys would know, it's mass production, or you can say scaling, right? So POC, you can consider, I'll come to the quantities now. People ask me this question a lot, like how many quantities should we consider in all of them? It totally depends upon the scale of manufacturing. So if it were Apple would be talking in different terms, right? Like MP for them is very different scale, and even Google, like it's very different scale. And like PVT for them is somewhere close to 10K pieces. They ship it out in the market, and they validate their production validation in that particular number. So 10,000 is there, and DVT is like what we validate on. You can say 500 pieces or 1,000 pieces. EVT is something that you validate for 50 pieces. This is where your engineering assumptions get tested, and like you need to be sure of the repeatability of your test cases. So all of your test cases should be repeatable. It shouldn't be that it worked in that last version. That never works in the product. So that may work in the POC or an MVP, but not after, shouldn't work after the EVT or a PVT stage, right? And in MVP, it's totally dependent. Like you can go as down as 10 pieces. It's totally dependent upon how many users you want to give it to, right? And POC generally is one or two, right? And if we like, you can assume the scale is increasing in each step. And PVT, you have to consider a scale which is with which you can test the production repeatability. It should be dependent upon the production capacity of the contract manufacturer or the manufacturer that you are in touch with. It is generally dependent on that. Okay. So just a full recap: POC, make it work; MVP, let users test it; EVT, validate engineering; DVT, validate design; PVT, validate production. right? So whether it's an Apple Watch or a Tesla car, this journey is gonna stay the same. And I really wish that I knew this while I was starting my career, because like I fumbled upon a lot of steps to make it happen to the PMP. But yes, experience teaches you a lot of things. But this is like not generally not like there in the textbooks of all of the engineers out there, but is there in some textbooks, I would say. Yeah. Sometimes even due to some business restrictions in startups, we might have to skip a few steps, right? So I'll give you an example. Like there was one time where we didn't do the PVT, but we combined DVT and PVT together. Right, like we had so the delivery was much more important in that particular setup. So we had to skip, or rather join two steps together to move first faster. Yep. So I'll just come to the careers part where we have this career paths that are possible in IoT. There are many more, and Preeti will be sharing a guide with you after this session of what all career paths can you follow in IoT. I'll be covering engineering, technical and non-technical as well. So obviously there's an embedded systems engineer, hardware engineer, firmware developer, the app developer. So there's a huge difference between a application developer and a firmware developer. But I would not cover that. I'll let the guide speak for itself. It has the key skills written as well. You can also consider a software engineer, a cloud architect. All of them are mainly engineering roles that you can take up to go ahead with your career paths. And most importantly, like what are the non-business non-technical paths that a person can take. So like product and design is obviously one of them. So a product management or a hardware PM, that is what you can do. And this is generally what a generalist does, right? And then there's a IoT UX designer post, somebody who's very keen into design, a human-centered design, prototyping and design thinking. They can get into this phase very easily, and you can transition from almost any dimension of design to this particular design very easily, because all the designers are mostly thinking about the UX part. And then comes the data and analytics roles. This is where frameworks are written for your AI to be trained on, right? So data scientists and data engineers, these guys can help you basically uh, do all the refinement of all of that bunch of millions and billions of data that is coming in from those billions of devices. And just one career tip: if you guys love hardware, yes, definitely you should go for embedded firmware or hardware roles. If you love coding, the cloud and data roles or software roles would be the best for you guys. But if you guys are a generalist like me, you can go for a solution architect or a product management role. Totally depends upon your technical expertise. If you are more techie, you can go for a solutions architect, and a little bit less, then you can go for a product management. So product management, you would need design side of skills as well as technical. So if you have both, yes, product management is the answer for you. Yep. I think that is it. It's your turn. So I'd love to hear from you guys. Like which stage do you think is the hardest? POC, MVP, scaling? Drop your answer in the chat, and you can ask me anything you want. And here's my these are my, you can take a screenshot here. You can connect with me on LinkedIn from here, and if you want to get a one-to-one mentorship, you can get in touch from here. Yep.
Okay. So can we move to the Q&A part, or still we have some?
Yes. So this is the Q&A part. Like this is the AMA section where you can do any you can ask us anything.
Okay, so before moving to Q&A, we have a session feedback form which I'm launching from my end, and I would like to request everyone, guys, please fill it out. It will not take more than a minute. If you have any suggestions how we can make these sessions more insightful. And if you have any topic suggestions also, please write it down for us. And side by side, we can take questions, sir, right?
Yep.
Sir, if you want, you can stop sharing your screen also.
Okay. Perfect.
Okay, so let's take first question. So what is your experience about the product getting modified between EVT,
Mhm.
DVT, and PVT? Was there any EVT1, EVT2 like phases?
Yep, that definitely happens. But you tend to try like validate all of these and do all of the versioning in EVT itself. We generally don't prefer to do versioning after EVT stage. So yes, in after MVP, you can consider there may be a few EVT1, EVT2 tests, even some EVT-A or EVT-B as well, because like A and B, you can test two different versions as well to validate your assumptions. So a fast charging or a slow charging version, what is getting more, much more um, uh, issues from the field, or you can say much more acceptance from the field. Yeah.
Thank you so much, sir. Another question. How about management people who want to implement and not go into technicalities?
So, from management side, there are two particular sides to look at it. One is the product management, one is the project management. So, generally, and there's another one, program management. I would not go much into details because, like, we don't have many experienced individuals here. But like, I'll first stick to the project and the product management side of things. So, like, you guys can definitely. So, there are many different versions of management. You can get into the non-technical part of things. There's a lot of operations involved in taking a product from zero to NP. There's a lot of operations involved in that. And what generally happens here is for product management, you have, let's say, that same example, any product, or your Apple phone would be one of the product, right? But there would be many projects going on under it. And when I say projects, one can be a better charging, better battery, bigger screen. All of these can be projects, right? Like, it totally depends upon how you break it down. So just to give you an example, there can be a power project which is going on to ensure the power delivery is better. There can be a connectivity related project going on inside, or this is something which you need to validate faster. You can go into project management, and you don't have to get into technicalities. All you have to do in project management is resource management, particularly whether you how many resources do you have, how many resources do you further need, and like, what are the timelines going to look like, what are the how would you manage the basically somebody's bandwidth if it's not available. Yeah. So I hope that answers the question. But yeah, I forgot one part. Just a second, Preeti. So product management is more like defining the vision of what we are going to build. And once that gets defined, there are a lot of projects involved in that. Yeah, go ahead.
Thank you, sir. Another question Apurva is saying, apologies, I am in the hospital taking treatment. My quick question is, how can we build video surveillance product? Can you guide us? How can we integrate video surveillance data on Google Cloud or any other you suggest?
So, for video surveillance, there are two kinds of. So, we need to understand whether it's a call or a stream. I would say it's a stream, more like a stream, right? Because it's surveillance. So, for that, you can look into RTSP, real time streaming protocol. You can look into that, and it's a very simple method to do streaming. Most of your CCTVs and most of your devices which are camera based are using RTSP. And yeah, like, I think that is the best possible available streaming protocol. But there's one caveat to it, that you need to have a lot of security on the application layer, because like RTSP protocol itself is not very secure. So on the application layer, you need to consider a lot about the security part, and maybe a assigned link or a temporary link, something like that. You can consider something like that to make it better. I hope that answers the question.
Yes, thank you. Another question Ram is asking, any facelift to the product is also need to follow the complete life cycle?
Generally, no. If it's a facelift, you have already validated your engineering validations. You have already done a lot of POC, MVP, and EVT cycle. You are past that, right? So you can directly jump into the DVT cycle. This is where you would pitch your stakeholders multiple different versions of that product, and like yes, it can be done parallelly. All of these things can be done parallelly, but you don't need to you need to go back to the EVT phase after this.
Thank you. Another question, Sharad is asking how to differentiate between which feature are important and need to be added in the product line. Like in one stage, customer give different requirement, and when we start working on it, their requirements change.
Mhm. So this is a very, very simple, very, not a simple, very common product management problem. That product, like the goalpost always keeps shifting because customer demands always keep increasing. Once you have given them a demo, or once you have shown them something, it just keeps increasing a lot of times. Yeah. So I can totally understand that part. We have been into that cycle many times. But to answer your question, it's always better to take a BRD. BRD. So generally, how it follows is there's a list of documents that follow all of these cycles. Similar to this cycle, which is a development cycle, there's another cycle which is which happens after the sales conversion, which is more important for the product management aspirants here. So it generally starts with the BRD, which is a business requirement document. This is the document which comes from your client, and this is where you can say yes, this was the requirement that you gave, and this is what you are asking now. So there's a change, and you can ask for some additional change request money for that. That's totally possible. But let's say if you are not able to follow this BRD thing, what you can do is, it's a simple email. You can ask the features, what they want to build, and you can document it yourself and make it a PRD. So generally, there are three documents which are followed in this whole approach. One is the BRD, which comes from the business requirement, usually your client or your sales team. Second is the PRD, which is the product requirement document, which comes from the product management people or product development people as well. So this is where all the lower level questions are answered, of how things are going to work, what why and how, all of them are answered here as well. The PRD, and once it is all done, then you can release an FSD. It's called a functional specification document. So I'll repeat again: BRD, business requirement document; PRD, product requirement document; and FSD, a functional specification document.
Thank you so much, sir. Another question. What is your experience in India for launching new products and startup? Is India is India IT industry is good for a fresher to do a startup? Also, what are the possibilities of getting sponsors? How did you manage all these aspects?
Okay, so how did I manage all these aspects? I'll come to that part later. And I think by sponsors you mean investors or somebody you can help you launch the startup, right? From up ground. So one thing that I would definitely recommend all of the freshers out there, uh, you need to understand. So I have been in this industry officially for 8 years, but I founded my I was part of the founding team back in my second year. I was 19 back then, and so that means I have been in this industry for almost 11 years, and I have seen a lot of failures. When you move fast, you break things fast, and that's only the only way to learn things faster. That's it. So as a fresher, my approach was always, and this is something that I recommend to all of the new hires, is that one, you show up, and second, uh, go work in a startup. I would suggest always go work under somebody first, just to understand how things work, because when you are fresh out of college, you tend to imagine that you know a lot of things. I also did that. I stumbled upon a lot of mistakes on the path, and that's how I learned a lot of errors with a and they generally come at a cost. So if you are okay to pay the cost, then yes, you are definitely okay to go ahead and start your own company. But like at the first thing, I would definitely suggest go work for a startup, because that would build your work ethic very, very nicely. And yeah, like, what are the possibility of getting sponsors? There are a lot of funds right now which are funding many people below 23, 24. There are a lot of funds and accelerators right now. One of them you can look at is, obviously, there's Y Combinator is there, and then Thiel Fund is there, Peter Thiel. That is a really good fund. And in India, there are many accelerators as well. So Axel is also doing that. So there are a lot of them. So if you just search startup accelerators in India, you'll find a lot. And yes, if you want to manage all of these aspects by yourself, I would never suggest doing it all on your own. One person can't do all of the things, so you always need someone you can rely upon. It's always good to have a co-founder or a founding team, rather, because they help you offload a lot of your responsibilities on their sides. That is what my job was in all of the last stints. Like, I handled one big chunk from CEO's responsibilities, and I freed him from those responsibilities so he can focus upon the company growth. That is what you would need.
Thank you. Another question. I'm from management in supply chain domain. I would like to optimize certain activity. What will be the roadmap from IoT side?
So it totally depends upon what kind of activity do you want to automate. Since you are from supply chain, I'm assuming inventory, or either inventory management or supply management, basically the finished goods shipping out, those things. So yeah, like, you don't need a roadmap from the IoT side for this, but rather uh, a whole system approach, similar to what you do for basically similar to very, very similar to what you do for definition or process design. That is the same thing that you would need here, but you need to really understand a few small things. One of them is API, how it works. One of them is a webhook, how it works. And that way you would be able to understand that on one side, where your supply chain operational people are doing something manually, or they may be writing it down on Excel, you can remove that manual effort, and you can give them, or not remove them, but optimize that manual effort and give them a QR scanner and implement QRs everywhere. So you can track your whole supply chain, finished goods and raw materials everywhere in the supply chain. That is what we did, like with our mass manufacturing as well. So we built a internal platform to track all of this, with a lot of, uh, you can say, app suites, small app suites, which automated this, or optimized this manual effort.
Thank you, sir. Let's move to another question. Uh, Currently, I am working in automotive domain. I need switch to IoT domain. What I need to read or any course, please suggest me.
I think I so if you once Preeti would be sharing this recording, at that point you can look at the IoT architecture, and you can go ahead and look for each of those parts online and study each of those parts in a little bit of detail. So one thing that you would definitely need for IoT is the MQTT side of things and the client and server side of things, right? Like you need to understand a little bit about how backend works, about how the MQTT part works, and as you could see in the demo as well, we were able to make a connection very easily. And just like to understand how a client and server works, it's a recommendation for everyone. Go ahead, open any website, be it any website. You can open Shine.com as well. That's not a challenge, and you can right click and you can inspect, and once you inspect you just go to the network part, and that's where you will see a lot of things popping up. All of those things are APIs, all of those things are constant communication happening between front end and the back end. So yeah, like that would be the can be your first step from switching from automotive to IoT to understand the software side of things.
Okay, thank you, sir. Another question, sir. You have said that when we get the deadline to release the product, we can combine, but do that mean that step can be skipped or considered with less effort, and what its impact on the final product?
So generally, the impact is on. So there's always a trade-off in every product. You always do a trade-off, and never ever a product is ever finished. So when you say a product is done, you mean that 95% of things are done, and you are still okay with those left 5% of things because they are the P2 right now, or the priority two right now. They have a lower priority right now, and generally the impact of this of skipping one of these things is dependent on the business actually, and the impact generally lies up in the quality itself. So it can be that the form factor doesn't look that good, or it can be that the functional aspect of it is totally fine, but there's some mild noise which is happening. If you guys have seen, there's a movie that I would definitely recommend all of you guys to watch. It's called Blackberry. If you've seen it, in the end you would see the inventor of BlackBerry, the initial inventor of BlackBerry, he was very obsessed with a small sound, squeaky sound that was happening. So sometimes you just ship with that, but sometimes you don't. So it's totally dependent upon what kind of trade-off is your business willing to take right now based on the timeline impact. So it's either timeline would increase and the quality or some feature would decrease, or it's the other way around. Like if like increases, the quality would also increase. It generally depends upon that. And you mentioned that the steps can be skipped or considered with less effort. Effort would be the same, I would say, but it's parallel most of the times. When I said it can be combined, it can be combined from two aspects. In my example, I covered DBT and PBT in one set. So imagine you started the DBT early on when you started the EBT. You started it parallelly, and you started the form factor ideation, everything in that particular phase itself. And like you have all of your, the variables in front of you, the design variables in front of you and your stakeholders, and they can choose any one of them. And you have with your during your engineering validation, your design is almost final, and you can ask your engineers to work upon this design itself. And this is how we squeeze our timelines. We are able to churn out one product in 6 months, and like in hardware it's very fast, I would say.
Thank you, sir. Let's move to another question. In India, IoT adoption is growing, but still behind the West. What do you think are the biggest challenges unique to India in scaling IoT solutions?
Okay, so India right now is, yes, you're right. There's a huge uh, backlog in adoption, customer adoption, because the infra is not ready right now. You can simply say, most of us would have. Uh, I'm sure like not a lot of us would be using smart home devices in India, right? But in the West, it is very, very common, right? So it's just about the cost of acquisition to that particular technology. India is a very cost sensitive market, and like whenever something gets developed here, it has to be developed for a very the acquisition cost has to be very low, or the entry cost has to be very low, that so to reduce the entry barrier. Look at Google, like what they did for startups. Google Cloud, if you know, they give a lot, and even AWS Cloud, all of them give a lot of free credits just to ensure there's no entry barrier. And then you once you are here, there's a free this is a freemium model. And like once you are adapted to that particular set of technology, then you won't be moving much from there, and that's when you pay. And similar thing happened with Google Photos. So if you remember, Google Photos used to be free, like it was free for a very long time, and then they started this 10 GB thing, and now you can only have 10 or 15 GB as free, and the rest you have to pay. So you can consider a similar approach for bringing new IoT products. And but yes, I think India has a lot of potential, since like because of a lot of schemes that are happening out here in India, the manufacturing in India would increase, and that would bring down the cost a lot.
Thank you, sir. Another question. What skills should freshers or professionals develop if they want to work in IoT?
I think I covered a few of that part in the slides, but yeah, I'll go over it again. So if you've seen like so it's obviously, if you are from technical background, you can consider all those technical domain that I've listed, and if not, then you can consider the product and the data side of things. I've seen a lot of people from non-tech background break into IoT just for because of their hunger to get into IoT, and you can either get from product or a data side. But that said, Preeti would be sharing this career path approach with you guys, and yes, there would be skills written as well to cover this part.
Okay, sir. Another question. Can you please share any real world solution in renewable energy sector which is easy to implement? What skills are needed?
So, okay, this is something that I have to think about. Just give me a second. So, like renewable energy sector, there's a lot of problems right now. Predictive maintenance being one of them. So predictive maintenance is basically like you can understand your solar panel or your windmill. Let's say a windmill. It's very, very high. Like it's almost like 100-meter high tower, right? But if something breaks down, the engineer has to climb up to the whole thing and figure out what has gone wrong. Then like he might have some spares and might not have some others, and he would have to repair that on site. But like I would suggest, predictive maintenance is one of the things which is everyone is talking about predictive maintenance and digital twins right now. So yeah, these two things I would say are good opportunity, or like for a renewable energy sector. um, you can say you can build a digital twin out of almost anything, right? Like you can input all of your variables and see what happens with that particular thing if the wind attacks from any X angle or Y angle, and you can play around with those variables and think about how you can make the performance better. And second is obviously what I said earlier, the predictive maintenance part, where you can implement a lot of sensors inside the hardware part, which gives you insight of the of the issue that can happen, so that you can take a proactive action, not a reactive action, Right now, it's mostly reactive action.
Okay, sir. Thank you. Another question. You have worked on everything. If you had unlimited budget and freedom, what's the craziest IoT product you would love to build?
First, I would not tell that openly. If I had everything, I would first go back and patent it, and then launch a company out of it. So yeah, that's not gonna be something. But yeah, like there are a lot of opportunities right now. If you think there are a few sectors which are currently very untouched, or with IoT, I would say. EdTech is one of them. Yes, manufacturing is another. Then like you can all, there's a lot of opportunities that are coming in with AI and IoT. Like you can implement AI on top of the data that the IoT is producing. So IoT is so there's a thing called digital transformation journey. It happens with every company. So every tech sector has this, right? But right now, there's a lot of focus on predictive maintenance. So yeah, like if I had a like huge amount of resources, I would put a lot of my money in a few of those sectors.
Okay, sir. Another question. With the rise of smart cities, what are the chances India will have a fully IoT enabled city in the next 10 years? Which one do you think will be first?
I think that's a bit like a tough question, I would say, because it depends on a lot of political variables as well. Not, I would not be picking something somewhere like in 10 years, because right now technology is moving so fast that we don't know what would be coming up in the next 10 years. Right, like in last 10 years, a lot of jobs that exist today didn't exist, and similar things are gonna happen, are bound to happen in the next 10 years as well. So, I would not say 10 years, but yes, 5 years down the line, I would say, obviously, there are a few tier two cities that stand a greater chance, because, like, tier one cities have a problem of resistance to change because of the massive population dependent upon them. So, yeah, like, there are some experimental cities being built around the world, which exist as a part of the tier two cities, which are completely automated, but not a lot of people are adopting them right now. I see the adoption rate to be increasing because of the AI and LLM adoption that is happening right now. So I see it increasing. But yes, I think tier two cities would be the first ones to go fully autonomous, rather than tier one cities, because a lot of economical changes have to be done in tier one.
Thank you. Let's move to our last question. Many say data is the new oil. In IoT, where billions of sensors generate endless data, do you think data ownership will be the next big battle?
Yes, I think that is what OpenAI is trying to do. If you see why everyone is trying to spend billions or trillions, almost billions of dollars, like I think SoftBank committed 500 billion to OpenAI last year, right? So you can understand it. It obviously goes in chunks, but OpenAI is building a massive data center, just to store all these data, and to understand what all do we do as people, right? Like how do we talk, what are our ideas, and to store all of that data. So yeah, I agree, you already see that move happening. So data is the new oil was used to be uh, the saying back in, I would say, 6 7 years ago, but it is currently the new oil. Like it is, the change is already happening.
Yes, one more question we got actually. So let's take one last question. Out of all the IoT products you have built, which one is your personal favorite and why?
Okay, so it has to be smart hat. I would say go ahead and look at it from like on Proxgy's website. It's called Smart Hat. This is the product which won the CES 2024 award. So like why it is first of all, what the product is. A smart hat is basically a smart hard hat, the same hard hat that industrial workers or mining workers would wear. But there's smartness attached to it. When I say smartness, it's an IoT product. It can collect a lot of data from this personal and give you real time alerts whether this guy is has fallen down, is not responding, and like he has been caught up in an accident. You can even do a video call right with that particular product. You can do an audio call, you can do one to one video call. So what it does basically is connects a blue collar worker to a white collar worker in a same way that we are connected right now. So imagine a blue collar worker like giving you a site visit without hands. So right now they're dependent on devices like a phone or a laptop, which are not built for industry. So yeah, that has to be my personal favorite, just because of the potential of saving lives. How many lives it can save, that would be very very crazy. Yeah, that has to be my favorite.
Yes, so thank you. So we are done with all the question. But before ending the session, any piece of advice you would like to give to the all the freshers?
Yep, I think to all the freshers out there, like things have never been more easier than today. Yes, there are many hurdles, but the entry barrier has reduced a lot. So back in like my time, we had to look up on how to do things on in books and on the internet, in the scattered resources of the internet. So it was like looking out from a blue ocean. But yes, we like a lot of us got lucky and found the right resources. But right now you have a co-pilot in your pocket all the time, and you can ask them a lot of questions. And I would definitely suggest you pick one side and do everything that you want to do in it, but don't just get stuck in that side. Be a generalist, because world is changing very fast. We don't know what's going to come next. And but I think one ability is the best ability. And this is the only skill that I would suggest everyone to work upon, is learning to learn. So that is the best thing that you can do. If you do that, you'll be a generalist in very short time. And once you have like reached to a point where you have developed a T-shaped career. When I say T-shaped, like you can say a depth in one of them and breadth in a lot of them. And once you have developed a T-shaped career, that's the best way to go in.
Thank you so much, sir. We are done with the session. Thank you very much for
Thank you.
delivering such an clear and engaging session. We truly appreciate you taking your time and sharing your knowledge with us. And a big thank to everyone who have joined us today. We hope you found the session useful and informative. And if you'd like to revisit the session or share it with others, the recordings are available on our LinkedIn page and YouTube channel. So until then, take care, stay curious, and keep learning. See you all next time. Thank you so much, sir, once again.
Thank you, everyone. Thank you.
Thank you. Bye bye. Take
Bye
care.
bye.